Hello everyone, welcome to today's live stream. So, I've literally just got back from work. As you can tell by my hair, I've just rushed quite a bit. So, we are here, we are at launch day. So, we are T-minus 12 minutes, 28 seconds. Yes, so this, oh, hello. My headset is going funny. There we go. So, I'm going to chuck their audio on. This is the NASA Psyche mission. So this is going to an asteroid in the asteroid belt around between Mars and Jupiter. This satellite is basically going to measure what the composition of it is, what materials, if it has a magnetic field. There's two cameras that's going to take loads of photos. But also there is actually a second satellite on this payload today. It is actually going to be for Deep Space Communications using optical, so lasers. And now you can see they're talking about Artemis 2, which is slated to launch next year, which is quite cool. Right, so I'm going to get their audio on.
Operations and checkout
there
building.
We go.
A test to practice a bit of what would happen before they lift off for the moon. Once their suits were on, they were off inside their brand new fully electric crew transportation vehicles for the 9-mile drive to launch pad 39B.
I still think the Model X is so much cooler.
Crew as they drove by. At the pad, Commander Reed Weissman, pilot Victor Glover, and mission specialists Christina Cook and Jeremy Hansen took elevators to the top of the mobile launcher.
When we walked out that crew access arm, I just had images of all those Apollo launches and shuttle launches that I saw as a kid, and it was unreal. I actually had to stop and just stand a moment in the crew access arm to really let it all sink in.
The day's successful test ended in the White Room, their final stop before boarding the Orion capsule to the moon. That's your Artemis Moon Minute.
Nice, here we go.
If you're just joining us, welcome to live coverage of Psyche. Liftoff aboard a SpaceX Falcon Heavy rocket is now just 10 minutes, 13 seconds away. Atop in the payload fairing is the Psyche spacecraft, which weighs just about 6,000 pounds when fueled. That's about as heavy as a large SUV.
You'll get your pictures, don't you worry.
It's made up of a body and 2 solar arrays in a cross formation, and when those solar arrays are extended, the spacecraft measures about 81 feet, or the size of a tennis court. It will be propelled by solar electric propulsion and will travel about 2.2 billion miles to study the metal-rich asteroid, also named Psyche.
You'll get your date, don't you worry. You'll get everything you need.
This mission, a mission more than 10 years in the making. Right. How are you feeling now with 9 minutes and 30 seconds to go before launch?
Oh my goodness, I have butterflies the size of pterodactyls in my stomach right now. But really, I'm thinking about the team.
I was at work today. I actually managed to finish early because I did a few over hours during the week, so I could leave at 2:30. I should have really gone at 1:30, but yeah, that was a bit of a mad journey. Hence the squash in a milk bottle, because that is what I do at work. This is going to be really cool. I love a Falcon Heavy launch. Yep, there you go, talking about me. So, actually, we have our Falcon Heavy diagram. I actually get my camera.
Jim, I really can't wait to see what you all uncover. You can't wait either.
There you go. So this is the Falcon Heavy. And basically 3 Falcon 9 boosters strapped together, and the normal top stage as normal. It's mad. It's just basically a giant Falcon 9 rocket. Oh, wrong way. I got too far. There we go.
We've got a number of things that we are going to be looking at as we count down to the final minutes, Mick, and one of them is chilling the booster engines, transitioning the
Yes,
power
they will come back down and land. So the two side boosters, as you can see here,
and the space
they will actually do a boost back burn and they will land back down on the land. So I think it's LZ1 and 2, I think they call it.
Internal power getting ready for this morning's launch, and we just heard they confirmed communication with the spacecraft after a short transition, and we'll verify the internal power here shortly. But things continue to look nominal for this morning's launch attempt.
Look at them fairings.
And we're hearing as we go along updates.
No boats today. Oh, let's hope no boats. Honestly.
Is complete. And we will also hear when their LOX is complete. We're getting now down to the final filling.
Nice.
Engine chill has started.
Is my seat falling down a bit, or I feel a little bit?
Those engines. And that's critical.
Oh, no boats for landing. No. Yeah, so no drone ships. The center core will actually be expended because they need all the performance of the whole rocket.
From that aspect, so
Whatever.
the LOX tanks and
Oh,
get ready for
so
moving into terminal.
SpaceX have just gone live on X, so we're staying with NASA for once. I can't believe I'm actually saying this, but look,
They are close
NASA in 4K.
RP1 load is
I
complete.
can't believe it.
Another booster down for RP1. Actually, 3.
Nice.
So now we move to the filling of the LOX.
God, it's quite warm in here.
For all
What's the
3
temperature?
first stage
28 degrees.
Okay,
Ooh.
and I'm good to run that now.
We love NASA. Yeah, we do love NASA now. SpaceX, you know, we're getting your own feeds.
listening in for the switch to internal power.
I wonder if they will show NASA. They were your first. They were my first love. Yeah, they really were. Space Shuttle. Oh, as you can see, Space Shuttle's that one now. Got the Saturn V just above. Normal Falcon 9 with Crew Dragon, and then Falcon Heavy, and then Booster 9 now. Man, look at that.
Beautiful shot of the rocket.
We've been there.
Spacecraft is on internal power.
We have been there.
Confirmation the spacecraft is now on internal power. The Psyche spacecraft
Nice.
that you see there, encapsulated between those two fairing arms.
Vehicle tanks are pressing for strong back
Here
recheck.
we go. Oh, actually, because this is not a military one, we actually will see more than just the second stage part. Atlantis opening day. Oh, what a great day that was.
Things are continuing
Oh,
to move pretty quickly here, Daryl, as the team preps for a T0.
Strong
we
back
were
recheck
this
has
close from touching
Now let's
a
take
space
view
shuttle.
up at the top of the
Mad.
rocket where we can see the clamp arms. They will begin to release the rocket just about the midsection of the rocket, midway up. We're also waiting for the NLM poll, which is coming up in just a few seconds. A final check with the NASA launch manager.
I've never
Tim
noticed
Jones,
actually
by launch director
the
Tim
strongback
Taylor of
is. It looks like it's like fabric.
Countdown net. LD.
Oh, here we go.
The NASA Psyche team is go for launch. Copy, go for launch.
Yes, come on.
Great news there. The spacecraft team is ready.
Oh yeah, I
Gen
haven't
Y
put
load
it
is
in.
complete.
Yep, and there we heard a call out for a
stop
LOX
poll.
load on one of the side boosters is complete as the team continues to fill the tanks and top them off, getting ready for launch. We should be hearing the other two side boosters finishing up along with
Right, the
stage
poll
two
is
Load
LOX
is
load
complete.
complete. There we heard the other side booster is complete with LOX load, Daryl.
These two side boosters, they'll be coming back today. So if you're here locally, you're going to get quite a show. Boosters 1064.
Oh, we've
and
got our votes
1065,
in. We've got one
which have
already.
flown 3 previous missions.
Now
2
I don't
DOC
think it will go boom.
and 1 commercial mission. They'll be coming back.
Oh,
about
elastic.
7.5
Oh,
minutes
it
after
did. Yeah, it
liftoff.
looks like an
So
elastic
look to the
band.
sky for that, especially that entry burn and landing burn. They'll make a sonic boom that you can't miss.
Yeah, absolutely. We are looking.
I need
forward
a
to
better look at that. I might zoom in later on.
Will be expendable. We'll use all the
So we've got 3 votes. It's not going to go boom. Okay. Well, Falcon Heavy is...
You'll notice there's no.
So this is his 8th flight of this actual rocket.
Done by purpose to make sure we
well,
get
not this actual
complete
rocket,
performance
but
out of that center core,
this
for that trajectory
well, the
that,
2
Charmaine
side
talked
boosters, I
about
think.
to allow Psyche
It's like
to
their
perform the
second
mission.
try, I
Always good
think.
to save some mass when you're flying a rocket
But-
to space.
Yeah, I think this is the 8th total flight
And those 2 side
of the
boosters,
Falcon
NASA has eyes
Heavy.
for them
Let me just move my
for the Europa
microphone.
Clipper mission.
We
It's
do
annoying me.
actually. The side boosters will be used on
Stage 2 lock load is complete.
stage 2 lock load.
Right.
We call out there that, but that's those side boosters.
So
will be
will it
used on
make
a Space
8
Force mission,
times in a row?
Later,
It
this
has
year
not
and,
yet
or
failed.
maybe early next year, and then we are looking to use as our prime side boosters for the Europa Clipper mission.
Jesse has just tweeted. We'll go for launch.
And with that call out that stage 2 locks is complete,
Look at that.
the Falcon Heavy is now completely tanked with 2.8
Damn. I know the feeling. I feel
of
completely
propellants.
tanked.
Getting into the final minutes of the countdown now. T-minus 1 minute and 37 seconds.
Oh, actually, look what I got
Gas
finally.
closeout.
I got a Nerf
So
gun.
you heard there the ground gas closeout.
But not only a Nerf gun,
See that burst of locks coming off the
I
side
got
of the rocket there?
1,000
That is
pellets
emptying out the lock
from
line in the transporter erector or
China.
strike pack.
Right, I'm going to end the poll in about 30 seconds. So if you haven't put your name, your guess down,
Getting down
chuck
to
it
the
down
final
now
minute
before I put it down. Take it away.
Falcon Heavy
Oh,
is in startup.
there's a dog barking. It's not mine for once.
Good call out that the Falcon Heavy is in startup.
Oh,
Now
it's
we're going to
in-
get the go at T-minus 45 seconds.
So at T-minus 30, I'm going to get rid of it. Go for launch. There we go. Nice.
We are go for launch.
We
All
are go
systems
for
are
launch.
go to send the Psyche spacecraft to deep space.
Right, I'm going to end our poll. So someone's put yes. Wow. Right, and the poll is ending in 3, 2, 1. Poll was ended. Nice, here we go. I'm going to turn up their volume so you guys can hear it.
15 seconds.
I'm going to turn mine.
And here we go with
Slightly
the
down.
final seconds of launch. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2,
There's
1.
the side
Engine
boosters.
ignition. And liftoff. Liftoff of Falcon Heavy and Psyche on a
Look at
mission
that.
to a metal asteroid in deep space to study the building blocks of our planet's inner space.
Vehicles pitching downrange.
M1D chamber pressure.
The
is nominal.
what? I can't see that. There's something in the way of my thing, Rich.
Camera on the booster. Beautiful shot there as it goes
Oh,
through the
wow.
clouds.
Oh, there you go. It's moving out of the way now. I haven't done the lemon tart. Oops. Whoopsie.
Power and telemetry nominal.
Over here, Joe, the power telemetry are nominal. We're also looking at the data
Oh,
for
wow,
all
that-
27 engines.
It's sort of getting a bit...
Supersonic.
All chamber pressures look good, and Falcon is supersonic now.
I have to say, I
Throttling down
do
in
think
preparation for
SpaceX
max
is
Q.
a bit better
A moment of peak mechanical stress on the rocket.
for tomorrow.
Max Q.
The side boosters will
When...
be at full power, and the
Oh,
center core
supper
will
time.
be at a reduced power to
Oops.
go through max
Okay.
speed to reduce the pressures on the structure.
I'll
of the
take
launch
them
vehicle.
moaning at me for that. That's fine.
Coming up in 30 seconds. We'll start getting ready to
God.
have those boosters cut off.
Right. So we should have the side ones come apart
Vehicle's looking
soon.
good, pitching down range. All telemetry looks really good
My
so
mouse
far,
go
Daryl.
away.
So we see a beautiful view of the Falcon Heavy and center core and side boosters there. Data is looking really good.
Oh, look at that. Oh, that's
27
nice.
engines of the Falcon Heavy, putting down 5.1
I do like this
million
side,
pounds of
like
thrust.
in between the two
Standing
boosters.
by
I
now
like
for
that.
booster engine cutoff for those side boosters. The center core booster will continue on.
Yeah, so the middle booster, the center one, is actually getting expended. So that'll just burn up in the atmosphere after it's done.
Booster engine cutoff.
There you go, look at that.
Booster separation confirmed.
That is so cool. And you'll see them, they'll
Great
flip
shot
back
there,
around.
the side boosters coming off the rocket.
They'll
And
flip
back
around,
engine
do a
chill has
boost
started.
back burn.
And there we start the chill on stage 2 as we get ready for MECO on the center core.
Boost back,
Stage
shutdown.
Stage 2 will
There you go,
continue
boost back, shut down.
chilling down, making sure the fuel and propellants are flowing through that MVAC, getting ready for ignition.
Those boosters will have 3 burns, 2 re-entry burns and 1 final landing burn before it comes back down at LZ1 and LZ2, landing zone 1 and 2 here at the Cape.
Nice. This is so cool. I have to say, I'm not liking the
Next up is main engine
quality
cutoff
of
that center
the
booster.
their one, but SpaceX on X is a bit annoying because you can't set a default
After that
resolution.
cuts off, there'll be a series of steps that will happen in close succession. Main engine cutoff. The center core stage will separate, and then we'll start the second stage burn, the first of 2 burns today.
There we see a shot inside
Boost back,
the.
shutdown.
There we. That was
Here we
a
go. So we should
shutdown.
have stage
Main engine
separation.
cutoff.
Inside the booster. There you have MECO.
We had the big engine
Stage
bell
separation
today,
confirmed.
not the short
and
little
there
one.
it goes. You're looking at the second stage in front of you,
boom.
lighting up its
MVAC
MVAC
ignition.
engine.
That is mental.
Split screen now.
Oh,
on the
that's
right-hand
nice.
side.
Center core FTS is saved. Bermuda.
Calling out the communication stations.
It's a
What a beautiful
bit.
shot there, while we had it, of stage 2.
So that's what the
There we continue to look at the side boosters.
Bearing separation
what's
confirmed.
on the rocket. The
Boost
rocket
back,
is
has been
the
completed,
payload
and they're in extended
is the
coast right now.
Psyche
There go the fairings.
satellite. So this is to go
Revealing
to
Psyche
a rocket.
To the atmosphere. You can see
It's
the
on a
fairing
rocket.
falling away back to Earth.
This is going to an asteroid
SpaceX has their recovery
between
vessel.
Is on an
Mars
all trajectory.
and Jupiter.
Their recovery vessel Bob is out in the waters right
Hey, Bob.
now, looking to recover both of them.
So yeah, it's going to explore a
Getting a
metal
good burn now from the
asteroid.
second stage. This lasts about 4 minutes.
Oh, I can hear someone clicking on a keyboard. Excellent game. Yes. It's bloody noisy around my area today.
We are going out over the Atlantic Ocean, heading south towards
South.
southern Africa.
South. It's going south. So it's actually going for a more... Going
On
for
the
an
right-hand side,
elliptical
you see
orbit.
the glowing engine of the stage 2. We've got 2 cameras there.
Never
On
been
the
a
left,
failure
we're
on the
tracking
second
those
stage
boosters
vacuum.
coming
Nope,
back down.
never has.
Yeah, we should see in about 20 seconds.
I was gonna
we
say, they've
should see
been
the,
very
booster
lucky
entry
with
burn,
that.
which is be the one engine on both side boosters.
Quite a clear image.
They
of
have
the
had a
space
couple
right-hand
on the
side. We've got
Merlin
clouds
engines,
overhead
though.
on the left, but you can see
It's
at the
how they
center.
lost a couple of boosters now and
We're
again.
tracking one of those boosters. Also tracking the second
Oh,
stage.
nice.
Like right there.
So if you look on the left, that
And
is
all the data so
the
far,
boosters
our
coming
telemetry is
back
looking nominal.
down.
I see the telemetry chilling down the engines.
Oh,
for
I need to move my legs.
Booster entry burn on the side boosters, starting up in the telemetry. Everything's looking nominal. The vehicle second stage is performing very well, and side
Come on.
boosters are coming back.
You can just see it, it's like just out of focus. But that tracking is amazing. Like, oh, here we go. We should see something in a
And then we
second.
just heard booster entry burn startup is happening. And seeing the entry burn getting ready to go
There you go.
on the side boosters.
So it's a little bit behind.
And there we saw the booster entry burn on one and shut down. And there we see booster.
I
entry
haven't
burn
yet.
on the
No,
second
I
booster
have
and
not
shut down.
checked to
Next burn is
see.
the final
Oh,
landing burn. And for
TYNY FTS is saved.
folks who are in
why did that look like the rocket exploded?
You end up hearing that loud sonic boom, that thunderclap, just about
Thunderclap.
the time they land.
Stage 2 is on normal trajectory.
No.
You and I here at Hangar AE, just a couple of miles away from this landing
Bit
zone,
like
you
a
certainly hear
TLI.
it and feel it.
Yep, and I see now that the booster side
it's not a
boosters are
rocket.
supersonic, transitioning to transonic.
And that's a shot of the booster
Oh wow.
through a
That's
thin
like
layer of clouds.
right underneath it.
Call out for transonic.
Oh
So,
shit.
Here it comes.
That scared the heck out of me.
I don't know,
What?
Daryl, but that sonic boom was great for us. I'm sure Jim is excited.
I was going to say,
that
where's
there's
the second one?
I'm sure the host desk over there is feeling that really well.
Literally, our monitors were shaking.
Nice.
Both those boosters broke the sound barrier.
I didn't think we were
Just heard
actually going to
booster
get the
and
sound
confirm, as we
of
see on
the
screen,
sonic
both,
boom.
And
back
back
landing
down.
zone 1 and 2, everything looks great. And then the call out for
Stage 2 FTS is safe.
Psyche 1, stage 2 engine cutoff. So Daryl, this
That
will
was
put
good.
us into
Oh,
that
I just heard a
45
bang
minute
outside.
coast that you and Jermaine were talking about, allowing us to do
Nominal
that
park
barbecue
orbit
roll.
insertion.
Absolutely, we're looking forward to
It's
that.
a
And as you
child's
look at the
play
screen
thing.
There are the two side boosters on their landing pads. Coming
Nice.
down more staggered than I'd seen them before, but nonetheless, perfect landings
Yeah, that-
for them both.
normally
And now
they'd
we
like
will
do 'em
continue to
together.
Track this right here, the second stage of the Falcon Heavy, along with the Psyche spacecraft, right there looking forward.
Is there a
You can
bird
see
on
the
my roof?
spacecraft on the right-hand side. It will be coasting now for about 45 minutes.
There you go.
And
It's flown
when we
away.
come back, we will bring you the moment of separation. In the meantime, we'll send it back to Megan and Jim at the host desk.
Oh,
And if you're just
that was a
joining
bit of
us,
a...
welcome live to Kennedy Space Center in Florida, where we just saw a Falcon Heavy rocket launch off with Psyche.
Jim's a
the
bit too
spacecraft.
excited.
Jim, speechless. Speechless. Actually, you weren't speechless during the launch because you were standing next to me, and he just kept on saying, "Go, baby, go!"
Oh, it was so powerful.
That's when
so
you have your
the
rocket
light, the
person,
sound.
and then you have a non-rocket
Yeah.
person.
It was shaking us as this thing goes up.
I saw the range of emotions. Like, you were super excited, and then you got quiet. You got really quiet.
Well, you know, there's a lot riding on this for the whole team, right? For all the
Yeah.
hundreds and thousands of people that have been involved with this. And it's just, what a great ride so far.
Oh, fair
How did you
play.
feel also hearing and feeling those sonic
Yeah.
booms? I was kind of
Boom,
worried
boom.
because we saw it in the video and we were like, are we going to feel it here? And all of a sudden,
Yeah, that was very exciting, very exciting. So,
That's quite funny.
Just
I'm
great
going to
job.
try and
Well,
open one of these packs of Nerf
use them for cover
bullets
next year.
without
Yeah.
making too much
Anything you want to
noise.
say to the team, again, as we just saw it lift off, you said all that hard work, all that time.
Yeah, no, this is just, it is a team effort, and, you know, we're going to be collecting this data set and studying this planetary core for future generations, really.
Yeah.
It's going to
Right,
be spectacular.
there we go.
Data, images, chemical data, magnet field.
And we're all watching a non-rocket
data.
person.
And really, you know,
Excuse
we can't
me,
study the
I
Earth
am a
core any
rocket
other way.
person.
So here's maybe how cores grow and what's happening inside our own planet.
Yeah. So
Effective
the
off the
Psyche
signal
mission is
Bermuda.
going to explore the metal-rich
Bermuda.
asteroid also named Psyche. And why don't we take a closer look at Psyche now? It was first discovered in 1852.
I almost shot myself in
We
the
don't
head.
know exactly what the asteroid looks like, but scientists have combined radar and optical observations to generate this 3D model you're looking at right now. Shaped like a potato, at its widest length, it's 173 miles. That's about the same as driving from Houston to Austin, Texas. There's evidence of two
that's
crater-like
big.
depressions. It appears to have a significant amount of metal, and a day on Psyche lasts only about 4 Earth hours. So,
Oh, I
as
like this.
Psyche's
This is fun.
imaging lead, tell me, when can we expect the first photos?
We are have to spend.
Okay, I'm gonna have
once
too
we
much fun with
complete
this.
the
I need to put it
deployment, we
down.
have to spend many months just checking out the systems, propulsion system,
I
communication.
don't know how long we got to
computer
wait till
systems,
separation.
everything, communications, and part of that is checking out the instruments. So I think the magnetometer might get checked out first because they're trying to detect some of Earth's
He
magnetic
is a
field
rocket
before we get too
person.
far away.
You just have.
And then in the weeks after that, we'll be testing
Look
out
at the
imagers,
nose.
taking pictures of stars, calibrating the
What are you
cameras,
saying?
getting
What are you
geometric
saying
correction
about
just right,
people with big
getting ready
noses?
for our eventual flyby of Mars, where we'll get lots of more great
To
pictures.
cross Sound Lake International.
And then, of
Oh,
course,
actually,
we'll start seeing Psyche as we get
I
close
can
to the end of this decade in late 28, early 29.
show you.
It'll go from that point of light that we can see in telescopes to its own little world.
Yeah, the fact that right now it's so far away, again, orbiting the Earth
Da,
between
da, da,
Mars
da,
and
da,
Jupiter,
da.
3 times
The
farther from the sun than Earth is. To
what was
be
it?
able to
The
study
latest
it now up
updates
close.
on
That's amazing.
Universal's Epic
And the fact that we're going so far
universe.
out to learn more about our home planet, I think that's so
Da,
fascinating.
da, 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 da,
This is something we're going to share
Orlando.
with the whole world, right? It's a point of light in the sky right now, but we're going to see it become a world as it gets bigger and bigger in the windshield as we get closer.
Perfect. Now, NASA's Jet Propulsion Laboratory in California is managing this mission. I also hear you're managing a very excited crowd right there.
Thanks, Megan. Yes, back here at JPL, there was so much excitement.
Right, what we're going to do, we're going to quickly divert.
And just take a live look
So,
inside Von Karman Auditorium.
our hotel is there.
Friends and family
That's
to come
Sand
here
Lake.
today and watch the launch
All
together.
of this
They're taking some photos
is
right now, and when the launch happened, the whole room started clapping and
Epic
cheering.
Universe.
They are wearing their
As you can see, it actually says Epic Universe.
Psyche may be off the ground,
But if you
but
check
the twin is still here on Earth.
the
It will see the on the spacecraft journey to a metal-rich asteroid. Psyche test engineer Joan.
here you go. So this is down towards the Florida Mall.
Tell us about it. Thanks for joining us, Joan. Thanks for
So this is actually
How would you describe Psyche's
an
test
old one. If I go to this side.
Psyche's testing
Oh, where is it? Okay.
and it is located at our
There you go. Here's a new one.
facility here in
So there is some hotels.
Now, the test
And if you look in the background,
from the mattress store,
you have
does it look like the spacecraft?
what are they called? Roller coasters.
And if you look at the picture,
So I went down to these traffic lights last time.
that is designed to have the same software.
So you can actually see this would be an entrance to Epic Island, Epic Universe, which is where we'll be coming in. Look at that roller coaster.
Exciting time right now.
How cool is that?
Closely following
Like, oh, it's so cool. The photos and videos I've seen. This was 7 months ago.
when we first communicate to the spacecraft.
So, oh,
And this is done through something called
I miss America.
instructions that we give to the spacecraft.
So that's the big bridge that, Martin, when you go over, you bounce about all the time.
We'll be making sure that
So yeah, it looks so cool.
testbeds are sending commands
2025 that opens.
would get.
So yeah,
If anyone in the team
that's gonna be really cool.
curious about a specific command, we would first test it on the testbed to see that we get the expected response.
Lots of work.
The expected response.
Yet. Tell us what's next.
Yeah, so of course I'll be celebrating a successful launch with my family.
Yes, you really are gonna have to wait. Yeah.
October is also a special month because
Yep, definitely. Book for 2025.
I was born in the Philippines, and so we'll be putting on an event that highlights both Psyche and our Filipino-American team members. And lastly, I'll be following Psyche's journey, making sure that our test beds are operating alongside the spacecraft.
Joan,
Nice.
thank you so much. I'm glad you were able to celebrate with family. Megan, back to you.
And isn't that one of the name of the recovery ships?
And we were
Megan.
honored to host JPL's director here at Kennedy for launch. She's with NASA's Jasmine Hopkins, and they had a great view of liftoff.
Thank you, Megan.
Oh, and you question what is JPL? JPL is Jet Propulsion Laboratory. I know that because Mark Robe. I'll be no, you won't.
So thrilling. So exciting to see that.
Yeah, Mark Rober, the YouTuber, used to work for JPL. He worked on the was it Perseverance? No, Curiosity even. Rover.
What do you want to say to the team at JPL and your partners about today's launch?
Hence why he knows a lot about mechanical engineering.
I'm waving to all of you right now. I will say I was
Hi, Mum, I'm on the TV.
in the hangar with the rocket. It was laying down, and I just took a few minutes away from the group to stand underneath the fairing and
That is pretty
think
cool.
about all the thousands of hands and minds and hearts that have
Oh,
gone
look.
into making Psyche possible at JPL at our partners. And
Math
I just
books.
couldn't be more thrilled. So
They've all got math books.
It's really like a relay race. You know, today's the beginning.
from Dexter's laboratory.
Before you get to Psyche, so what's next? What's the work being done at JP?
I love it.
So right now, it's all about picking up from the launch team and getting our spacecraft separated from the rocket.
Bloody pigeons are on my roof. I'm sorry, I can't help it.
To get us on out to Psyche, 2.2 billion kilometers away. Yeah, exactly. A lot. Look forward to. Thank you so much, Rocco. Thank you. Of course. Psyche. Yeah, go Psyche. Megan and Jim, back to you.
The Psyche mission is a collaboration between NASA's JPL, as we just saw, Arizona State University, and NASA's Launch Services Program. And
oh man, how long is this going to be?
People who made this mission possible.
At the end of the day, it's always a philosophical question, right? Of why are we in this universe?
Space just inspires.
Oh, Falcon Heavy 1. Oh.
So I think it gives, in a sense, kind of hope.
That was the first one. I remember where I was when that took off. I was on a bus on the way home from Farnham, and I just shouted out, "We just put a Tesla in space." And everyone was like, "Oh, that's quite cool."
My name is Christina Hernandez.
My name is Vina Shrikant.
Hello, Christina.
I'm making sure that we built a spacecraft that's ready to explore a metal world. What's really exciting about Psyche being a metal-rich asteroid is we haven't yet had the opportunity to explore.
Do they fit my nostrils?
Core, and that's what we actually.
Yes, they do.
There is a theory that this metallic asteroid may be very closely related
Oh
to
God.
the materials that made up.
I'm trying to think what you're going to make me do now.
It's been the remnant of a planetary collision billions of years ago in our solar system. All that's left is the metal-rich remnant.
Scientists hypothesize that by studying this asteroid,
There we go.
It can give us a lot more insights on what our actual planet is doing.
So this is the Psyche spacecraft. We're basically looking at a spaceship that's going into space.
Do you know what's crazy?
Welcome to High Bay 2.
I find this crazy that literally they're all wearing like clean suits. They're in a clean room.
this is where I work.
And yet,
Power supply.
SpaceX are making a rocket in the middle of sand dunes in Texas. Like, it is crazy.
Reach Psyche and send back science data.
We formed a really, really critical team.
The diversity of skill sets that each one of us in our community brought to the team to make this kind of impact to society is what inspires me to be an engineer in the space exploration sector.
I like it.
Now, Jim, we just heard from some of your colleagues. Tell me, what does it feel like for you to be part of this team?
Oh my God, it's such an amazing team. And you saw some examples.
He loves rockets. You can see it.
All kinds of engineers, all over mechanical, software, communications, propulsion, power. You know, every kind of engineering you can imagine. But it's also we're working with managers, administrators, communications experts, educators. I mean, it's just such an amazing collection of people, a community of people that it takes to make
what
this
you
kind of
get up to at work is your business.
Yeah, and somebody said, you know, what inspires them?
Oh,
what inspired you
God.
to be a part of Psyche and to want to go into this field?
You know, when I was a kid, there were astronauts driving cars on the moon on TV. And it's
Well, it wasn't really a car, it was a rover, but okay.
And I've always just been hooked on it. Had a telescope when I was a kid, got to know the night sky, and just been really fortunate to be able to pursue all this as a career.
Yeah, I can still feel how emotional this is for you. Are you okay? We're back to excited. We're back to
Oh,
excited.
sorry.
All right, it's now
I'm
been
tired.
about 20 minutes since launch. Let's go back to JPL and
Am
Raquel
I-
again for another update on the Psyche spacecraft.
Oh, here we go.
Raquel, the mission support area is working in shifts, yeah?
Oh, look at the behind her. You've got all the. So you got look like two sending out and two receiving.
Who will work to make the spacecraft fully
That was quite cool.
Joining us now is Psyche systems engineer Christina Hogstrom, who tested the spacecraft and can tell us what comes next. Good morning, Christina.
Good morning, Raquel.
So tell us what you'll be working on when you take over this workspace.
So right now we're waiting for the launch vehicle to get into position to let
Very
go
cute.
of Psyche. And after that point, we'll be monitoring closely and waiting for that first signal from the spacecraft. Once it separates from the launch vehicle, Psyche is going to autonomously turn on its radios, deploy its solar rays, and then put itself into a slow spin at 1 revolution per hour. And that's to keep the temperatures uniform, which is why we call it rotisserie mode. Once it's in that spin, the antenna that's beaming the signal to Earth is going to be rotating in and out of our view. And so it could be anywhere from a couple minutes to a couple hours before we hear from the spacecraft. But as soon as we do, we'll look at the data, we'll make sure that it's still healthy, and then we'll start talking back to it.
Yes, the UK were like the leaders in electric vehicles for many years.
And we heard from Joan that there is
They didn't go very fast though, did they?
twin on Earth, but you actually tested the spacecraft itself. What kind of tests did you do?
Oh yeah, we really put the spacecraft through the ringer. I helped to coordinate this test where we put the entire thing in a giant vacuum chamber. We sucked all the air out.
12 miles an hour, jeez. I could run faster than that.
We made it super hot, we made it super cold, we made it hot again to make sure that the spacecraft could operate in those extremes of deep space. And then there was another test where we put it on a big table and we shook it to simulate the launch vibrations that it's seeing today. As much as we can over and over, we've checked every wire, we've tested every function on the real spacecraft as long as it's safe for the hardware. Anytime we have a brand new version of the software that's on board the spacecraft controlling it, we always test that in the testing twin first to make sure it works. And then we still prove it out on the real spacecraft. And the whole process is iterative. So we start on the testing twin, we test something, we learn something.
I like her eyelashes, they're quite cool with the flick.
We move it to the real spacecraft, we learn something, we fix it, and we start the process over. And that's why it takes us years to be absolutely sure that we're ready for today.
Sounds like it is ready for its journey. Now, you've been with the mission for 4 years.
Damn.
What is happening next for you?
Oh my goodness, it is surreal. This is my first flight project, and I've just learned so much. I've had the
I would be able to. I'd be able to run that fast, even now. I might need my asthma pump afterwards, but I'd be able to do that.
Early on, and nowadays I'm on the operations team as kind of a systems generalist. I've seen this thing grow up from designs on paper to a robot that's on its way to space today, and I just am so super excited to continue on and fly this thing that we've worked so hard to build. The next 100 days are going to be pretty crazy for the operators. We're going to be checking things out, turning things on for the first time, making sure that everything's going swimmingly. And then we'll have a much more relaxing cruise to the asteroid, and I just can't wait to see what we find when we get there. I'll be on this journey to a metal world every step of the way.
Thank you, Christina. Back to you, Megan.
She's like, I'm going to be on it 24/7.
Sent them in. Sent them in. Jim,
yes.
Are you ready to answer?
I am ready. Bring them on.
I wasn't ready to say that, but now I'm ready. Okay, so let's play the first question.
Yeah, around the year.
I am Paola and I'm from Serrano Elementary School in Moreno Valley, California. And my question is, how much time is Psyche gonna spend studying Psyche 16?
It's a great question that Paola asks. And so first of all, it's going to take us almost 6 years to get there.
That's
right? So we have to fly by Mars.
Damn, 6 years.
Power ourselves out with those.
I'm going to be 37.
And then when we get to Psyche, we'll start up high.
Holy cow.
In this 33-hour orbit, and we'll spend a little more than 2 years, 26 months, slowly getting.
So by the time I'm like almost 40,
higher and higher resolution, and map this whole thing and get its chemistry and make.
You can't be Dad's kid.
Stuff. So about
why?
26 months.
Awesome, great question, Paola. All right, let's take the second question now. How can an asteroid have enough mass and density to support a molten metallic core?
That is an outstanding question, and
that sounds like an adult question.
This asteroid was part of something much bigger, right? And so it had more gravity, and with that gravity comes internal heat, pressure, internal heat.
Oh, I love it. I love it. I ain't stupid.
Forming, and so
I'm
it's
just
really hot on the inside, and it can get molten.
Dumb.
And we think that the part we're seeing now is just what's left over after maybe a big impact.
Oh, we've got views.
Knocked off the mantle and crust. We're going to test that hypothesis with.
That's cool.
Okay, let's squeeze in one more question. This is Andy Zhang on H.
Mate, he just saw that as well.
To research and develop this mission and the Psyche spacecraft.
Well, it's the better part of 10 years.
Yeah,
you know, we saw earlier in the show that, you know, it all
There's
started
literally
with some
pigeons on my
a
roof.
whiteboard, and, you know, folks thinking ideas about how can we learn about planetary cores, how can we figure out how planets form. We can't study the Earth's core. Hey, let's go visit a metallic asteroid that might be the remnants of a core. And so that idea from sort of 10-ish years ago became a proposal, a pitch to NASA.
Oh, look at that. That's nice.
That we won. To mount a Discovery class mission, and the spacecraft started getting built. We got selected in 2017, and in probably about 2018 or 19, we started building and testing the spacecraft. Here we are in 23, and it's off the ground.
And you know what? I just realized I never said congratulations to you.
Thank you. The whole team. It's really, like I said, everybody.
And choosing a fisheye lens, Martin. Don't be so fooled.
But right now, I need you all to take out your phones or get ready to take a screen grab if you're watching us on your phone. We're going to pull up another QR code for you. And this one will take you to NASA's Eyes on the Solar System page. This is really cool. You can track the Psyche asteroid's current location along with other asteroids and comets in our solar system. And once the Psyche spacecraft is communicating back with us on Earth, then you can also track its location. Now, the Psyche
What's wrong with pigeon and squirrel?
That will be studied by researchers around the world, including the curator in charge of the U.S. National Meteorite Collection at the Smithsonian Museum of Natural History. Take a look.
I'm going to load my Nerf gun.
I thought I wanted to be an astronomer. I took a geology class, and there was just something about having a rock in your hand, something you could hold and feel. I thought, you know, we have rocks from outer space. Maybe I'll
something about having a rock in your hand. Yeah.
I study meteorites. I love meteorites. It's like an addiction for me because I love.
This guy's a virgin. I'm sorry.
These rocks and the places
he is a virgin.
Life on Earth exists on two heat engines. One is the sun, but the other is the heat engine below our feet. That drives the movement of the plates. It drove the differentiation of the planet. We've known for 2 centuries that our core was made of metal, but we haven't been able to explore it. We can't drill a hole that deep. We can't explore with any kind of submersible in the oceans. What we've been looking for years is a metallic asteroid, something that's very dense. Psyche is an asteroid 200 kilometers across, thought to be metal rich. Psyche is our way.
Imagine if they get there and it's just dirt. Oh, look at that.
Meteorites fall to Earth. Some of them are little tiny pieces. Some of them are the size of cars. But compared to Psyche, they're just tiny little specks of dust. When I first started as a graduate student, we had never visited an asteroid. Not any of them. Asteroids were points of light in the sky, and now they're real geologic places. They're places we can visit.
And can you imagine, literally, they get there, and it's just dirt, and they're just like, well, that was not worth it.
And that's why this part is so important.
Could be nose dust.
Right now,
oh, God.
That will determine whether we get the data that graduate students 10 years, 20 years, 30 years from now will learn things about this asteroid that we can't even imagine today. It's the journey of a lifetime, and I didn't want to miss it.
It would be quite cool to see the photos in that.
This fall, Asteroid Autumn, for all the fascinating things we have going on with asteroids around our solar system. For more on that, let's bring back NASA's Jasmine Hopkins.
Hey, Jasmine.
Yes, 'tis the season of asteroids. Here to talk to us more about Asteroid Autumn are
Can't
Nikki
wait to
Fox
see
and
Bruce.
Lori Glaze. Thank you for
Bruce
being here.
Almighty.
We are so excited. So we are in Asteroid Autumn, but no 2 missions are the same. Nikki, Psyche.
You have a misfire.
Well, first of all, Psyche just launched. So, I mean, it's right, awesome. So, but Psyche is going to a metal-rich asteroid, and there are only 9 that we know of in our solar system, but Psyche is huge compared to the other ones. It's the
Get off my roof!
So we're going to go and actually visit a metal world for the very first time. We don't know what
this is what my streams are going to be now, me shooting pigeons.
Every time we launch a mission, we do unique cutting-edge science, and this one is going to be absolutely no different. We cannot wait to get that out
She's
there,
stuck.
that spacecraft out there with Psyche.
Exactly, that was the perfect way to characterize it. We keep doing unique first. So actually, Lori, you were just in Houston as well as the administrator for the unveiling of the OSIRIS-REx sample return. So what are we finding with that mission? What is next?
That is an amazing mission, and as you said, I was just
I've
in
broken it already.
Houston 2 days ago on Wednesday. It was absolutely spectacular to be there and share with the entire world kind of our first look at what that sample is.
Oh, Bruce Willis.
The very beginning of the analysis process.
Oh, I was thinking Bruce Almighty for some reason.
Science to do, but what was so unique about that particular sample was we're finding water in the sample. We're finding carbon, an incredible amount of carbon, more than we've ever seen even in the meteorites that we have here on Earth. So there's just so much new discovery to come. Keep tuned on OSIRIS-REx over the next several months.
There we go.
I'm sure there'll be a lot more great new.
I haven't broken it now.
And we're actually not at the end of asteroid autumn yet. The Lucy mission is about to have a close flyby. Its first asteroid encounter since launching in 2021. What are we looking to find from that?
So again, we're going to be going to an asteroid. It's a little one, so it's very, very different from Bennu, and it's different from Psyche.
There we go.
And we're just going to learn a lot.
I fixed it.
It's going to be the very first time that we've actually visited this new world. It also gives us an opportunity.
I've upgraded the spring in this.
And make sure everything's ready for when Lucy actually gets into the Trojan belt and starts the flybys in there. And I have to just give a shout out to DART. It's also part of asteroid autumn, and we just celebrated that 1 year anniversary.
Some come out really fast, and some just like.
I'm going to tell you why Lucy is so important.
Yeah, so the Lucy mission, as Nikki said, of course,
There's
is gonna
one
fly by
stuck
a little asteroid named Dinkinesh, and it's a main
inside, and I can't get it out.
The real goal of Lucy is, at the end of this decade, is to explore several what we call Trojan asteroids. And they're Trojan because they kind of hide, right? They're
I can't get it
find
out.
the Trojan asteroids leading and
Come on.
trailing Jupiter.
Yes,
in
there we
its
go.
orbit around the sun. Interesting fun fact, those asteroids, even though they're in Jupiter, the orbit that Jupiter's in around the sun is actually closer to Earth than Jupiter. But those asteroids are incredibly important for telling us about the early part of the solar system.
Not
where
bad
the
for a
giant
£5 in a
planets
charity
were,
shop.
if they migrated or moved over time. Those asteroids were picked up and held in that gravity field over
Oh, look at that. That's pretty cool.
Different asteroids we're going to visit will tell us about that history.
No, it's not a knockoff. It is actually Nerf.
Thank you, Lori. Thank you so much for being
It is
here.
a proper Nerf gun.
Of course, go.
It's
Psyche.
just
Jimmy, back to you.
it's second hand, isn't it? So.
I love to see how
But I've
excited they
upgraded
are. I
the
also love that
spring.
We do have this big screen there that's showing you the trajectory again of that second stage with Psyche. Now we are 33 minutes since launch. Once this Psyche spacecraft is on its own, the spacecraft will use solar electric propulsion
Take it
to move
back.
through space. Now that's a super
I'm not
efficient
doing that.
system being used for the first time beyond the moon. First, Psyche's solar arrays will convert sunlight
When is this going to happen? Tell
that
us.
electricity will power the spacecraft's
I might
four-hull
check.
thrusters. Those thrusters will use electromagnetic
I'm gonna
fields
check
to
Twitter
turn
quick.
Psyche's propellant xenon into thrust, and that thrust will gently propel it through deep space while emitting that cool blue glow you just saw there on your screen. Now, Jim, when we're talking about gently, it is very gentle. Can you tell us about that?
It is very gentle. How gentle is it? It's so gentle. Hold out your hand.
Okay.
I have 3 quarters here.
All right.
It has about the same amount of force as those quarters.
It feels like nothing.
Nothing.
Absolutely
it's like
nothing.
a bag of feathers,
Yeah.
right? I mean, it's very, very gentle. So tiny but mighty, right? Because you exert that force over time.
Oh wow,
just
SpaceX have not gone live for this.
So instead of just like one big main engine burn,
Wow.
it's just a slow.
So it's
gentle
actually
process.
NASA's stream is their
And that accelerates us out
stream as such.
25,000 miles an hour on our journey out into the solar system.
And that's essentially because
They're
even though
cutting
it's nothing,
costs.
if there's no atmospheric drag
They
to
are
push it
cutting
back, it
costs
just keeps
a lot.
accelerating.
Exactly.
Interesting. Wow.
Wow.
Now, Maxar Technologies supplied Psyche's 4 Hall thrusters. You can see them there.
We're about
Engineers estimate
20
that
minutes
if this
away
mission
from
used traditional chemical
the
thrusters, it
burn.
would have burned
I've just
through
seen it
about
on
15 times
SpaceX
as much propellant.
tweets.
Now, Psyche is carrying 3 science experiments on board. Check out how they'll discover the asteroid's composition without even landing on it.
Psyche.
Right. While this is going on, I'm going to quickly pop to the toilet.
Psyche is
So I'm
this
going to
really
put.
unusual body
I'll
giving off
be
really
right
unusual
back.
gamma-ray
See you guys in a
neutron
sec.
signatures.
Technically, it's an M-class asteroid out between Mars and Jupiter.
One of the first things you want to know is what's it made of.
So the Psyche payload consists of 3 science instruments. One of them is what's called a gamma-ray neutron spectrometer. It's actually 2 separate pieces of hardware. One is the gamma-ray spectrometer and the other one is the neutron spectrometer. Both combined study the elemental composition of Psyche.
If you know the surface composition, what it's made of in terms of iron and nickel and silicon and oxygen, you can then start to say something about its history and how it formed and how it evolved.
By using gamma-ray spectroscopy, we can measure those elements remotely. We don't have to touch the surface. We don't have to dig into the surface.
For Psyche, we're building kind of what we call the Cadillac. It's a very high precision, high sensitivity instrument. It's very similar to the Messenger instrument.
That technology that we developed for the Messenger spacecraft gave us a huge head start going to Psyche.
For our types of instruments, we don't get to fly them very often. So when we actually get selected for something, that's a big deal for us, where we can, take what we learned from the prior missions and implement it now and make an even better instrument.
Our instrument is kind of like a camera without a telephoto lens.
In order to get our best measurements, we need to be relatively close altitude above the surface. That's what we call orbit D.
So we can form maps, global maps, of the elemental composition of Psyche just by flying around externally.
You have galactic cosmic rays. That's a fancy word for very fast protons. They come in, they smack a planetary surface, they bust apart the atoms in that surface, all the neutrons rattle around, and as they rattle around, they end up producing gamma rays and neutrons that come out. And the gamma rays have energies, and they're like a fingerprint. So if you get the fingerprint of different energies, it says, is iron there, is nickel there, is silicon, and then how many of those gamma rays tells you how much of that element is there.
The first thing it takes to do a mission like this is a tremendous amount of institutional knowledge of all the different aspects, not just how do you build something, how do you aim something, how do you guide something, how do you get data from something, those technical aspects.
I feel like it's super important to have a team that you can trust, because you can guarantee that at some point something's going to go wrong, probably many things over the many years of a project. So already it's happened that in my process of learning about the science, I've made small changes to the design to help optimize and help meet the science goals.
We're kind of the last instrument to get its measurements.
And so there is a sense where you're on pins and needles until you get that data back, and then there's a big relief, there's big excitement, and then you get to work and trying to say, what does all this mean?
So we'll deliver some excellent science at the end.
And active checkout of the instruments starts about 6 weeks after launch. Jasmine Hoffington's got to speak with NASA's chief scientist, Kate Calvin.
Welcome, Kate. Thank you so much for joining us today. So Psyche is going to take us to a metal world for the first time. What scientific discoveries are we looking forward to?
Well, the Psyche asteroid could be the metallic interior of the remains of a small planet. So this will give us an opportunity to understand how planets like Earth formed. So 4.5 billion years ago, all the planets on our solar system formed from the same cloud of gas and dust. And Earth has a metallic interior, but we can't bore down deep enough to see it directly. And so by visiting Psyche, we have this window to understand the processes that led to creation of planets like ours.
And it's going to take us a while to get to Psyche, about 6 years. So what are the long-term benefits of a mission like Psyche?
Well, from a science perspective, scientists are hoping that it'll help us better understand planetary formation, including the formation of planets like ours. But Psyche also has a technology demonstration along with it. So it'll be a test of communication from space, the next generation way of communicating from space. So the Deep Space Optical Communication will be the first test of laser communication from out beyond the moon.
Right, so we actually have two firsts attached to the Psyche mission, Psyche and DSOC. And once we get to the asteroid, we're going to be taking all these pictures, and then those pictures will be open to the public. So why is it so important that NASA makes science accessible for everyone?
So NASA makes its science publicly available, and we're working across the agency to make it more accessible so that more people have access both to the information, but also understand what we do with that information. And by opening science up to the world, we can do more and do it faster. So when we bring more people in and include them in our science, we can ask more questions. We can also answer questions more quickly. And this isn't just something we're doing with Psyche and with planetary science, but we're doing it across the Science Mission Directorate.
Exactly. We're actually doing it with Earth as well. We have the Earth Information Center now at headquarters. Can you tell us more about that?
Yeah, so Psyche is going to give us a little more information about metallic cores, and Earth has a metallic core. What the Earth Information Center tells us is a little bit more about what's happening on the surface of the planet and what we can see when we observe Earth from space. So we can learn about things like land use and land cover, we can learn about ice, we can learn about what's happening in the atmosphere and how that all impacts people here.
Exactly. Thank you so much for being here with us today, Kate.
Thank you for having me.
NASA and the Psyche mission team love engaging with the public and especially students. One program invited undergrads to share their creative works inspired by Psyche. So let's take a look at some of those submissions now.
Yeah. This is awesome.
That's so
I
cool.
love the way that we have artists and dancers and poets and writers and playwrights, and this is spectacular, beautiful views. There's
the colors
there's our
for
mission
this one
color
is great.
theme right there. Yeah.
And I love 16 Psyche is scripted right there, really
with
pretty.
the spacecraft with its deployed solar panels.
Yeah.
Yeah, this is just beautiful stuff. Look at that.
That's cool. Look at the detail on Psyche there. Are your pictures going to look as good?
Just exactly. Yes, we certainly hope so. But boy, it's just beautiful fun to imagine.
Yeah, and it's so cool to see that both science and art, they can inspire one another.
Absolutely.
So,
Expect lots of signal, hard to be stuck.
Now, if you want to see more artwork and other projects inspired by Psyche, take out your phone and scan another QR code we have for you on your screen. This one's going to take you to psyche.asu.edu/get-involved. Okay, and I do know that you have other space arts. You're just so full of demos and props. I love it.
Space rocks, right? And I have a couple more space rocks. This is a slice of an iron meteorite. Let's see if I can hold it up to the camera there. It's a slice of an iron meteorite that's been polished. And you can see the beautiful grains. And there we go. You can see the grains in it.
So
and this is a mixture of metal and silicate rock.
Yeah.
And so this might be not polished, but might be what the surface of Psyche is like. But it's also, it's just beautiful. People put these on their mantle place and in their rock collections. You can collect these.
You said make
as well.
jewelry too,
You can
right?
make jewelry out of them, little earrings, a pendant, whatever.
That's cool.
I have another piece of space art. This is also a space rock. Let me hand this one to you. Tell me what you feel.
Oh, that's heavier than I expected.
Very
wow,
heavy,
that took
right?
me
It's
aback.
a sphere that the artist has kind of carved out of a much bigger metal meteorite, and you can see all the little grains, and it almost looks like a little mini Death Star, right?
It does,
and so people collect these and trade different ones with their friends, and so there's lots of ways to use space rocks for art too.
Yeah, thank you for sharing those. I really appreciate that.
Sure.
All right, it's now been about 44 minutes since launch. Our coverage is again going to take you through the deployment and first possible signal from the Psyche spacecraft. So let's check back in with Mission Control at NASA's JPL.
Thank you, Megan. Welcome back to JPL. We may be 2,500 miles away, but I can tell you the community feels connected. And here's a live look from Von Karman Auditorium. Just moments ago, it was packed with nearly 200 family and friends. This is where JPL hosts special events, and it's also where we display several spacecraft models. And there's a model of the Psyche spacecraft that I had a chance to see up close with payload manager Noah Warner. Take a look at why he says you can compare parts of the spacecraft to an electric car. Great to have you here, Noah. Tell us more about Psyche.
Yeah, I'd love to. So we're standing here with a quarter scale model of the Psyche spacecraft. And you can see even at a quarter scale, it's a very large spacecraft. The actual Psyche spacecraft is over 15 feet tall and 80 feet wide, and at launch it weighs over 6,000 pounds fully fueled. Let me point out a few key features of the spacecraft. You see up top here is the high gain antenna under this silver blanket, and on front is one of our 3 low gain antennas. Also on the front of the spacecraft is the NASA technology demonstration instrument called Deep Space Optical Communications.
Psyche will use a special kind of propulsion system. What can you tell us about it?
That's right. We use solar electric propulsion. That means we gather energy from the sun through our 5-panel solar arrays. We convert that energy into electricity and use that electricity to drive our Hall effect thrusters, 2 of which you see right here. They're 4 to 5 times more efficient than a chemical rocket. You can think of a chemical rocket almost as like a gasoline-driven, high-performance sports car with lots of acceleration. Whereas our Psyche system is more like your highly efficient electric car that gets you everywhere you're going on the minimal amount of fuel. Hall effect thrusters use xenon as the propellant. They ionize that propellant and accelerate it out at tremendous speeds. They also generate this beautiful blue plume.
Wow, and right now it's packed up in the spacecraft. How do we get it to look like we see it right now?
That's right. At launch, these 5-panel arrays are stored flat on the side of the spacecraft. And a series of cables, springs, latches, and dampers will choreograph that deployment such that the first 3 panels in line here will deploy first, and then the side panels will come out one at a time after that. And then the spacecraft will start looking for the sun and get those arrays pointed directly at the sun to get full energy. At that point, the spacecraft starts a rotisserie move where it rotates about once an hour, establishes communication with the ground, and then the operations team can start to check out the spacecraft and get Psyche ready for its journey.
So what are you looking forward to on Psyche?
I think I'm looking forward to the science investigation and, frankly, the fact that we're going to a world that we've never seen with our own human eyes. We don't really know what we're going to see there, but I think we've got the exact right suite of science instruments to figure it out once we do get there.
Thank you, Noah.
Riding along on Psyche today is NASA's Deep Space Optical Communications Experiment, or DSOC. It will be the agency's first test of high bandwidth optical or laser communications between Earth and beyond the moon.
In our everyday lives on the ground, we use optical fibers for really high-speed communication, and that capability has been adapted for use in space near Earth. DSOC stands for Deep Space Optical Communications, which is using lasers to communicate at high rate, and the application of that to deep space beyond the moon is what the DSOC project is about.
Primary objective is to give future NASA missions the tools for returning data at much higher rates.
The signals travel at the speed of light, so they come just as fast as they do for the microwaves, but you could send more data in the same time of a pass for the same spacecraft resources. The notion of being able to communicate, have video to astronauts on Mars is actually part of the vision that NASA has for optical communications. DSOC consists of a flight terminal that flies on the Psyche spacecraft, and then a ground network that has a station for transmitting up to the spacecraft and then receiving the laser signal down from the spacecraft.
Here we have to send a laser beam from Earth that the spacecraft has to receive, use as a pointing reference, and then initiate the communication link. So it's a very flight and ground joined at the hip kind of telecommunication system.
DSOC is being implemented as a technology demonstration to show that we know how to build terminals that can do this, with the idea that in the future they can be flown as part of the operational communication system on future missions. And we designed the terminal to operate out to about Mars' farthest distance. And Psyche on its cruise actually does a Mars flyby, so it's an excellent vehicle for the demonstration of deep space optical communication. DSOC is the first time that there'll be optical communication demonstrated beyond the moon.
The leap that DSOC is taking is huge. I can't express in words, what this will mean to actually see bits that were transmitted from deep space spacecraft received on the ground, and we can verify that, hey, we got the bits that you sent, here they are. Before that moment of elation and joy, there's a lot of work that we still need to do and think through.
And so this is a stepping stone for a future operational capability that NASA is committed to. There's a lot of activity in space and a lot of collaborative work that goes on, and it's very exciting to be part of.
MVAC engine chill, burn 2.
Now to tell us more about DSOC, we have its operations lead, Meera Srinivasan, with Jasmine.
Thank you, Megan. So Meera, we just saw a beautiful launch, but now the work really starts for DSOC. So what does mission success look like to you?
Right. So, the purpose of doing optical communications is to be able to transmit much higher data rates than what we can do now with radio frequency systems. So, for us, the bottom line or ultimate measure of success would be for us to demonstrate those target data rates that we've established for ourselves over the course of the mission. But just kind of beyond that, I think this is a technology demo. So what we really want to do is learn. And we have deployed all kinds of technologies, both on the flight side as well as on the ground side, in order to achieve these goals. So really, what we'd like to do is get enough data back so that we can understand, do our models work, how does our hardware perform, and what we can do to improve our operational concepts so that we can kind of mature this technology and bring it to the point where it can be fielded operationally. So that's mission success, is basically learning as much as we can.
Right, we're looking forward to that. And you're mentioning this data. So what information will DSOC be transmitting?
So what we're going to be focusing on primarily is this kind of test pattern data. This is what we've been using on the ground as we were developing the system. And so we'll focus on sending that initially. It's essentially like it's a test pattern, something that's pre-recorded, and it allows us to characterize the performance of the optical channel.
Right. And Mira, I mean, this is going to be a long-term mission for Psyche, but how soon do we expect to hear back from DSOC?
So provided that all the checkouts go as planned, approximately 40 days after launch, we hope to be getting some data down.
Okay, great. We're looking forward to that. Mira Srinivasan, thank you so much for being here today.
Well, thank you for having me.
Of course. Megan and Jim, back to you.
Now let's get to some social questions again. Jim, you've been doing a great job of answering them, so I hope you can continue your streak.
Let's do it.
All right, let's play the first video.
Hi, I'm Diego, and I'm from Serrano Elementary School in Moreno Valley, California. My question is, how long will it take Psyche to orbit the asteroid?
Good question.
Diego knows how to ask good questions. Absolutely. Yep. So we start up very, very high as we approach the asteroid, going to very high orbit. And it's about 33 hours for the spacecraft to go around Psyche once, and we'll slowly lower that orbit, lower, down to about 4 hours. We're about 75 kilometers.
Hello, everyone.
Miles or
I am back.
above the asteroid at our lowest.
And we do have one time
So
for
where
one
are
more
we?
question. We have
Oh.
this one from X, Space
That
Space
sounds
Terra
like
on
good
X.
timing.
What are you most excited about to learn about Psyche, considering how the Bennu sample was so incredibly cool?
Yes, boy, what a great success for that, for the OSIRIS-REx.
Oh,
It's
man.
spectacular. Of course, we're not taking samples from Psyche. We're doing what's called remote sensing,
Mm-hmm.
but we will be able to measure the chemistry, to look at the geology. We'll be mapping this asteroid just like the OSIRIS-REx team did with Bennu.
It's
So
very
we'll
cool
learn
what
as
they did
much as we
to
can,
OSIRIS-REx.
just short of bringing a sample back. So
Okay.
maybe in the future, decades hence, maybe we will go and bring some samples back from Psyche. But this
Once
mission
we're
will
living
take
on
us-
Mars, it'll be
Okay,
easy
looking
to
forward
get there.
Maybe that.
Let's do it.
All right, thanks again. If you haven't sent in questions
that
yet,
is
it's
engine
still time.
chill.
Again, use hashtag AskNASA. Okay, we've been following along with the Falcon Heavy's second stage as it continues its journey out with Psyche.
Come
Let's
on.
bring back NASA's Daryl Nail and
back
Nick
ignition,
Wilton
burn 2.
for the next operational milestones in this mission. Guys, go ahead.
Yeah, there you just heard it, and you can see it. The engines start for the second time on the second stage of the Falcon Heavy
Nice.
rocket, now flying through space close to the country of Australia. And you can see it there. We've been tracking it all along, watching the fuel get prepped and prepared to restart that
Very
engine.
cool.
Make this burn roughly about 2 minutes and 9 seconds.
Yeah, this burn's very important to get Psyche on its way. And Daryl, as you said, we've been tracking that, and as throughout that 45-minute coast phase, there have been call-outs for different ground stations that have been used around the United States, or around the world actually, to track this second stage. And you and I have been continuing to watch that telemetry, and this vehicle so far has performed very well today, and looking
As it
forward
would
to this
do, you
final
know.
burn to get ready for
SpaceX
spacecraft
rocket
deployment.
always
Those
does.
tracking stations that you mentioned, as we've heard them called out throughout the broadcast, also helpful with bringing us this picture right here, that high definition video pictures from space, which we greatly appreciate seeing and are able to show you exactly what's happening. As the spacecraft approaches the northwest coast of Australia, it will continue flying over the Indian Ocean. We will get ready to end that second burn and then prepare for the big moment, Mick, and that's separation of the Psyche spacecraft.
There was a spider
Yeah,
on my
that's what,
microphone.
Jim and I know all his team are excited about. We are too. Great successful launch today, watching that Falcon Heavy come back, those two side boosters land. But it's all about the Psyche spacecraft in this mission, and that's what we're very happy to be doing today, to deliver this on orbit and get Psyche on its way. And we are so happy to be a partner with JPL and the Psyche team to do that. So very looking forward to that video of separation.
So the burn about to come to an end here in just a few seconds.
Is
And
my
back shutdown.
is my audio okay, Mark? Does that sound okay?
There you hear the good call out of the MVAC shutdown.
Because I'm just checking my audio and it doesn't
Cold
look
darkness of space. We are in
enough.
orbital night on the other side of the planet from where we launched this morning.
Nominal
lifting off,
payload deploy, orbit insertion.
Oh, here we go.
confirming the
Okay,
orbital
cool. That's
insertion
good.
there.
So yeah, it's confirming that we hit our mark exactly on that trajectory and where we needed to drop Psyche, get ready to drop Psyche off, as Jarmaine had pointed out earlier in a segment on the trajectory. So that's really good to hear the stage 2 perform.
Look at the glow of that
perfectly
engine
today,
bell.
And we're getting ready for for this last
can hear it.
prior to Psyche deployment. As you can see, the spacecraft right there on the front of stage 2.
Yeah, there it is, the Psyche spacecraft attached to the second stage. The camera looking forward where we can see that will be the image we will be looking at when separation
okay.
happens.
Yeah, I have got their audio a bit lower.
As it goes along, of course. We lifted off today at 10:19:43 a.m. Eastern Time, 14:19:43 UTC time, and we've been flying for almost an hour now. And again, the teams at JPL certainly paying close attention. Along
look at the bit of ice.
Both here in California, or there in California, and here in
So they
Florida,
must have a
they're
light.
locked into this moment about separation.
Yeah,
they must have lights on the actual second
the
stage.
Launch vehicle team is actually continuing to watch as they secure the launch pad here, and everything is going well.
Get my mouse out of the way.
Teams are excited for this moment here. This is what it's all about: spacecraft separation.
And here is some of that team at the Mission Director Center in Florida. And now you're looking
where
at
is the
team
rocket going
in Pasadena,
to
California,
once it's
at
dropped
JPL,
its load?
the Jet
Oh,
Propulsion
I'm
Laboratory.
guessing it will
This is the
do
control room
what's
where
called a
we will run
deorbit
Psyche.
burn.
We'll be monitoring
So it'll get
the
to its
second stage
apogee,
and Psyche as they fly, and, we'll be
and then
back
it
in
will
just a
just
little bit,
point
but for now,
basically
back to Megan and
backwards
Jim.
and fire
Luckily,
backwards,
loving
and
those
then
live
that
views
should
of
make
the
its
team
perigee, which is
spacecraft
its
there.
lowest
So
point,
why don't we actually, head
just in
back
the
on
atmosphere.
over to JPL in
So then when it comes
California to
round,
hear what's
it'll
happening now
just
as they check
hit
out the
the
spacecraft.
atmosphere and then burn up.
Thanks, Megan. We are about 1 hour
Oh,
after
how
launch,
many are
and
now?
now everyone at JPL is eagerly awaiting the next major milestone. Here is a live look from our mission support area. There was a shift change just a short time ago. Right now, they're preparing for initial acquisition of signal from the spacecraft. I'm joined now by Psyche Flight Systems Manager Mark Brown, who is responsible for spacecraft development. Thank you for joining us, Mark.
Thank you.
Basically, it
Now,
is
you
going to
were part
burn up
of
in the
that
atmosphere,
countdown
yes.
shift. What was it like witnessing launch with your team?
Oh, it was very satisfying.
Why has he got his
the end
eyes
of a long
closed?
road for us developers, but then this is the start of the journey, you know, that the spacecraft's going to take. We're very confident in how the spacecraft's going to behave. We've done all the testing and analysis that relates to this. There's always a little bit of nail biting that goes on with these things because you can't exactly test that exact ride to space.
Yeah.
But we're quite confident. The other thing I would say is that we're relieved to have gotten to do launch today. There's a lot of moving parts with these launches. As you know, we got people in Florida, people
the
here,
eyes are
people
open
working
now.
off shift times.
Every time
And
he
just
looks at the
knowing that
camera,
we're
closes his
launched
eyes.
will allow everybody in their personal lives to kind of settle down. We now know what the schedule will be, you know, going on from here. So.
And what can we expect to see next from Psyche now that it started its journey?
Right. What's really going to happen just in a matter of moments is we separate from the launch vehicle, and now the vehicle's really on its own. On the ride up, it was on battery power. So when we get those solar arrays deployed, we'll be, you know, looking to basically get to the arrays on sun, okay? And then we'll be looking for that first signal. And the first signal isn't necessarily a data stream like you would think about. Anybody of you that, you know, in your house, if you're looking for your Wi-Fi, you can see that signal, but you don't necessarily start getting, you know, Google and on the internet, right? So the carrier comes in first, and then we'll kind of sync up, and we should get the data coming in.
And what kind of data will you expect to see from Psyche?
There's a range of, first of all, I'll say, is that, you know, the spacecraft exists to carry the science instruments, but the science instruments are hibernating. They are off for launch. So we don't really see anything from the instruments themselves. We get some temperature data and, you know, and some health data on those
electrical
instruments.
stuff
but
like
what
that.
we're probably most interested to see is, you know, are we power positive? Is the battery recharging, or are we still draining it? And then we're also going to be looking for, are all the temperatures kind of within safe limits, nothing too hot and nothing too cold? And those will be big indicators of, you know, that we're good to go.
Well, thank you so much for that information, Mark, and joining us today.
Right. Thank you.
Back to you, Megan.
Back to you, Megan.
We're soon expecting to see the Psyche spacecraft separate from the Falcon Heavy's second stage. We have an animation of that right now. Let's bring back Daryl and Mick. Everything still tracking, guys?
It certainly is, Megan. We are watching now, as you can see on your screen, the Psyche spacecraft looking forward from the second stage, as well as keeping a track on what's behind it as well, going between the two views. But
acquisition of signal, Hobart.
Oh,
there's just a call out that they've reached their next tracking station along the path that Psyche is taking. But
Is that...
the big show is
Oh,
right
that
there.
was looking
shot
down.
right
You
there,
can actually see
that is
stars.
Psyche spacecraft pointed into space. We
So
are
there's stars.
orbital
That's quite
nighttime,
cool.
currently flying. We've overflown Australia, approaching Papua New Guinea, where we are tracking a separation time in just about in just a few seconds. Stand by.
Here we go. So we're going to see this bit here, this big black bit, just separate. There we go.
Payload separation confirmed.
There it is. The Psyche spacecraft going off into deep space.
That is
2.2 billion mile journey.
Yeah, I'm going to tell you that is an amazing shot right there.
Oh, there's that girl
I'm so excited
just
to see
down
that.
there. She's like
Probably
this.
not as excited as Jim, who's up at the host desk right now, but that is an awesome shot to see Psyche leaving the stage 2.
You see the team right there in the lower left-hand right corner. They are anxious.
Right,
as
so
they
now
see
it is
their
actually
baby
starting to
go off
pitch
into space
up
towards
and
an
around.
asteroid named Psyche, same as the mission. As you look at that Psyche spacecraft, you see the large diameter circle, which is where it attached to the payload adapter. That circle down at the bottom, that's a low gain antenna. And that low gain antenna will play a key role. It's got 3 of them. There's 2 more on either side. So if that one is the bottom, there's 2 on either side. It will play a key role on when we get that carrier signal that we just heard JPL talking about.
Yeah, I'm going to tell you, in all my years,
So they're
of,
literally
doing
just
launches,
waiting
Daryl, that
for
was a beautiful sight.
a signal.
I think that's the longest I've been able to see a spacecraft deploy. So that's an amazing job by the SpaceX team on that camera work on the second stage.
And so we'll keep tracking this as well, listening in for that signal. Momentarily, we're actually going to put up a waveform monitor where we're actually going to be looking at the signal, whether or not we can see, actually looking to see whether it comes in or not.
That'd be quite
a little
cool.
more inexact, because as he described, JPL in the earlier interview, that spacecraft is going to start rotating as they try to lock that low gain antenna to a receiving station back here on Earth that JPL will see.
Yeah, I like the way he described it, like your Wi-Fi in your house, right? You find a signal, but you don't
You
quite
connect to it,
start
but it doesn't
receiving
connect
data
to the
and
internet.
getting on the internet yet. That's kind of what they're looking for from the spacecraft here, that low gain carrier signal that they can know where Psyche is and that they've made contact with it.
That's
and
not
then they'll
bad.
continue to monitor that and so that they can then sync up and start getting the data and then starting their next 100 days of operation with the Psyche spacecraft.
All right, we just saw the Psyche spacecraft separate and go off on its journey into deep space towards the
Deep
Psyche asteroid.
space.
We are now monitoring its progress to see when it makes that carrier signal back down to Earth, but we'll send it right now back to our other Earth partners, Jim and Megan.
Well, Mick had said it. Mick, there was a lot of excitement here when we saw Psyche separate, but now I feel like there's a little bit more of an anxious feeling because now we're waiting for the carrier signal, right?
Yeah, so we've just seen this beautiful wild animal released into its native habitat.
Okay.
Right? This is where that spacecraft belongs. This is what it was built for. Let's see if it phones home and
Oh
get it going.
God.
Yeah, exactly.
E.T.
And while we wait for
phone
that, let's take
home.
some more social questions. Again, we've asked people to send them in using hashtag AskNASA, and we've gotten a couple of them. So why don't we show the first one now?
Hi, my name is Santiago, a student from Tetre Porter Elementary School. My question is, why do you guys think Psyche is a core of a planet?
Wow, these kids are asking awesome
I
questions.
know, I love seeing
Santiago,
kids
that's
ask
a
these
great
questions.
question. So there's 3 pieces of evidence. One, we can see the colors, the way that the asteroid reflects sunlight.
It's a
Looks
giant
lot
rock
like those
of
metal
metal.
meteorites I showed you earlier. Also, astronomers can bounce radar waves off of Psyche from the Earth all the way out to the main asteroid belt, and they bounce back and very, very highly reflective, not quite like a mirror, but clearly suggesting metal. And the third piece of evidence is that when we can watch its orbit wiggle a little bit when Mars passes by, or when
So there's
Jupiter
some
passes by,
sort
or when
of...
Psyche passes by another asteroid, its orbit changes a little bit. So we can get its mass, we estimate its volume, also from telescope data, and that gives us an estimate of density. And its density, it's heavy. it's not that light granite rock, right? It's more like that heavy metal meteorite, that sphere that you held, right? It's really dense. So we know that there's a metallic component in this one as well. It's one of the densest asteroids we've been able to measure.
So you guys do know a lot about it. Now it's about going out there and checking out to see if your hypotheses are correct.
True. It's still a point of light to us in the sky. We have to get close to it to turn it into a real world.
Okay. Let's take another social question now. This one is from Christelle on Twitch. Is there a chance that the asteroid contains water?
Probably
That's a great
not.
question. We don't really think so.
Okay.
But it might have some material on the surface that is more silicate rich, not so metallic. Maybe it was hit by other meteorites like the one that we just brought the samples back from OSIRIS-REx, which turns out to have a bunch of water in it. So there could be little places on the rocky parts of Psyche that have some water, but probably as a whole, we think it's mostly just metallic.
Got it. Jim, thank you so much for
It's
answering
metal.
those
It's
questions,
a
and thank
big
you to everyone who
ball
sent
of
questions
metal.
in. Okay, so to recap, the Psyche spacecraft has been deployed and is now floating out in space on its own. The launch team is looking to confirm a signal from the spacecraft. So Daryl and Mick, how's
You
that?
have a question. Go ahead.
We've been flying for 1 hour.
Tell
and
me
8
your
minutes
question.
Now through space, and there you see, I believe we have
I see
signal.
See the spike right there.
Could there be a Nando's on it?
Clapping.
Oh,
like that
there we go. We have a signal.
The low carrier signal that they're looking for. So that
I
is
wish
good
there was a
news.
Nando's on it. It'd be
We've
quite
received
funny.
That carrier signal, and the team will begin their work.
And what you're looking at there in the lower left-hand corner of your screen is the receiving station for JPL, and they got that carrier signal, which came off of Psyche's low-gain antenna. It sent out that signal. There's not a lot to that signal. There's no data, no telemetry, just a basic signal that says, hey, I'm here, I'm out in space.
Yes, basically as Jim said, phone's home, lets them know
Yep,
where they
it's
are.
my
that they
belly.
can
Yep,
start working,
definitely.
To get their stuff set up.
My
and start,
belly.
Acquiring data later on and beginning that next 100 days of operations that they need to do. So, very excited for the Psyche team, spacecraft team. Successful launch of a Falcon Heavy today. And now they have contact with Psyche, and they can begin the work they've been working on for the last several years.
As for the spacecraft, what it's doing now is getting into a mode to deploy its solar arrays.
Solar arrays.
Get those arrays out, get it pointed in the direction of the sun, get that spacecraft power positive. And this is a process that, as
Takes
they go
hours.
through that, ultimately will lead to a lock on a telemetry signal, potentially several hours from now, where they can get a data stream and learn about the health of the spacecraft.
Yeah, absolutely. That's what they're looking for, and that's what's exciting for them to get these things started. So very excited to watch that and bring things to a conclusion here for this mission as we are, Daryl. But the Psyche team still has a lot of work ahead of them.
Do you know what?
They got to go,
I really
fly
like
Mars, which is their first destination in about 3 years.
Yeah.
Oh.
And another 3 years after that, they'll be on their way to Psyche. So, of course, congratulations to the JPL.
So they're going to use a
LSU,
Mars assist.
NASA, SpaceX, everyone who's participated in making this mission a success. And
Actually, yeah, this is the right time to go to Mars.
I appreciate it, man. Another great, successful launch, and I would say to Jim, congratulations, my friend, and go Psyche.
All right, we'll send it back to Megan and Jim at the host desk.
Thank you, Daryl and Mick. Always good to do a broadcast with you guys.
Those guys are great. Those guys are awesome. Yeah.
Now, Jim, you
Them guys are great.
imaging lead, obviously so invested in today's mission and all these milestones. I'm telling you, sitting next to you, it's like riding a roller coaster. So, like, deployment, you're like, and then it's back down to the carrier signal. And then we get the carrier signal, and you're like, And now we're waiting on solar array deployment. That's the next big thing, right?
Right. We knew, even when we were writing the proposal many years ago, there would be 2 early critical events, right? We just saw one of them, the beautiful
Carrier.
SpaceX launch.
And then the
KSC team delivering us to the right path, we're going the right direction. The second one is that deployment of the solar panels. You saw that they're all kind of folded up against the side of the spacecraft, so they need to spring out and deploy so we can go.
so many satellites have failed doing that. Like they've not been able to open the solar panels.
And I know, again,
Like we were very lucky with James Webb's telescope because that actually had a problem with its solar panel.
Also cheering there once Psyche's carrier signal was confirmed.
I like this like blue LED
Megan,
stuff.
that's right. Now let's take a look again into the mission
Really
support
like
area.
that. I think it's really cool.
Moments ago, we watched the team cheer and celebrate. Some of them were even standing up for it. But there is still more to come, and we are now joined by Lena Hutchinson, who is part of the Psyche launch team. Now, you're the launch activity lead, which means you're in charge of verifying the spacecraft and its behaving as expected through launch. So, Lena, lots of work leading up to this moment. What does this mean for the team?
It's really exciting. It's really special
Now a drink.
to kind of know that the spacecraft is alive and healthy. So that first little blip that we saw was our first indication that separation was successful, and we are on our way to deploying our solar arrays. And hopefully we'll soon start to see actual telemetry where we can start verifying power and temperatures and a lot of other things like that. So it's really exciting, and for me personally, it's really special because this is the first mission that I have actually worked on that I got to launch since I started JPL. So it's extra exciting because now we're finally here, we're in space.
Well, congratulations on your first mission, and the work doesn't end here. So tell us what's next for Psyche and you during its long cruise.
Yeah, so as we keep going, we will start checking out all of our instruments, all of our hardware, making sure that everything's
Get some photos.
doing okay. So we'll be checking out all of the data and making sure that everything is doing well. And I will be continuing on with Psyche. I will be continuing as we checking out all these instruments and helping out and supporting the team with all that work.
Nice.
Now, in your support role, we understand that the first 24 hours may look different from the first weeks or months. What's that like?
Yeah, so our main goal right now is to make sure that the solar arrays are deployed and that our telecom system is working, which means we can actually start sending and receiving data and commands. And that is like the most important thing to focus on right now, because those are the things that we absolutely need to be able to continue on.
Absolutely have to.
Be able to talk to the spacecraft. So that is the main focus for the next day or so, and then as we continue, we'll start.
Do you think matey in the back over here, do you think he's actually doing any work?
Great. Thank you so
or
much.
is he just posing?
Now, Megan, that will do it for us here at JPL. The mission support area will continue to wait for acquisition of signal, which is expected to happen within the next couple of hours. So we'll send it back to you in Florida.
Wow.
Great, Raquel, thank you so much. And back here on the Space Coast, you can see that Jim and I are not alone. We are now joined by Diana Calero from NASA's Launch Services Program. Today, she was filling in on console as the Assistant Launch Manager for Psyche. Important role, another successful mission for you guys. Congratulations.
Thank you very much. It was great. We had a great count. Actually, it was pretty clean. We got over a few issues early on in the count, but then everything was very quiet. Everything was very clean. Of course, we had some worries about the weather coming in with the 30% violation, but then
there's never a worry.
We got a great.
The fact that SpaceX have launched in 50% weather,
for the 45th Space Quadrant,
85 is beautiful.
Chance of violation, which was awesome.
Yeah.
So going in, everything was nominal. There was a little bit of drama there, maybe in the last 5-6 minutes there when spacecraft was transitioning to internal power and they weren't quite getting their telemetry. They couldn't verify it, so everyone was holding their breath there for a little bit, but then they got it and everyone's like, everyone let out their breath at the same time. But we had a beautiful launch, as you saw.
Yeah.
The recovery went well. Everything has been nominal second stage.
I want to know why they are doing staggered landings now for the boosters. Because that was like a thing.
Again, this doesn't go
was the double landing, like right next to each other.
The Psyche spacecraft team, including Arizona State University, JPL, everybody. It was incredible. The range, 45th Space Quadrant again, giving us lots of weather updates.
Sure.
You know, we had to stave off the first attempt, but everything worked out great.
Yeah.
Super team effort. Now this was NASA's first primary science mission launched on a Falcon Heavy. So why did NASA choose this rocket?
So for this mission, based on the size and where it was going, right, interplanetary mission, we need the performance to be able to lift that up. Falcon Heavy had that performance, met the requirements. It was great. Falcon Heavy, when we selected this mission, was a fairly new vehicle coming out for SpaceX. So we had to certify this vehicle, actually. NASA, we can't launch until we certify the launch vehicle. Psyche mission is what we consider a Class B mission, very important science mission. So we had to certify. It was a multi-year effort.
I'm guessing A is like crew.
That we had to look at, qualifications. Had a lot of boards looking at scrutinizing it technically to make sure it was a low-risk vehicle for this mission. So
it is a low-risk vehicle. It's got 100%
Thank you for choosing the vehicle.
success
It was a
rate.
wonderful show with the launch and then the side boosters coming
Pass
down.
along our thanks for a great ride.
Yeah, thank you. It was an honor, and we're proud to be able to launch Psyche, and looking forward to getting some good science and being able to use that.
Yeah, how does it feel to be part of that, to be part of Psyche's journey out to discover things about
So this
our own
girl,
planet?
she's really good at
I'm
interviews and
so proud to
stuff.
be a small part of that, right? I mean,
She's very
come
good at
years to get Psyche
getting
to this
information out.
level, right? And then even though we worked this mission for many years before, I feel it's just a small part of what that Psyche, that cog in the wheel to get that Psyche and that science back, right?
Yeah.
How long it's going to take to get there, and then come back with the science, and then use that science in a way that's going to benefit
Very
mankind.
important cog. Very important.
Teamwork, guys.
Teamwork's the only way.
Thank you, Diana. Now, before we sign off this morning, let's take one last look at today's spectacular.
Oh, here we go, the replay.
15 seconds.
Oh, look at it. It does look quite
Final seconds of
quite
launch.
big.
T-minus
I mean,
10,
it is quite big.
9, 8, 7, 6.
So just think, that height alone is the height of Booster 9 with the new heat thing on the top.
And lift off.
I can't remember what they call it.
Of Falcon Heavy and Psyche on a mission to a metal asteroid in deep space to study the building blocks of our planet's inner space.
So this has 27 engines. That's crazy.
M1D chamber pressure is nominal.
Bloody pigeons on my roof again. I'm gonna get some spikes.
And that'll do it for us here at Kennedy Space Center for this live coverage of NASA's Psyche mission. A huge congratulations to everyone involved, and a big, big congratulations and thank you to everyone who participated, especially you, Jim.
Oh, that's very sweet. It's such an amazing thing.
Yeah, it's very, very sweet.
I'm thinking of the team right now, right? I mean, hundreds, thousands of people around the country, around the world, that all have to come together and make this happen. So many skills, so many sets of experiences, so many stories. So much adversity. This was done during COVID.
I was just going to say challenges.
COVID,
yes,
right?
yes.
And people overcame that, and now our spacecraft is on its way, on its journey.
And so what's next?
What's next is that we spend the next few months, we've got to deploy those panels and get power positive.
I thought you were going to
Yes,
take a time to breathe,
sure,
Jim.
there'll be a little partying, I'm sure, responsible partying. But we have to spend the next few months checking everything.
Mate, he's going to be getting lit tonight.
All the instruments, all the calibrations, all that kind of stuff, and we're just super excited to get going on this.
Yeah, literally. Cannot wait to see what you guys uncover, because again, we are going to uncover something about our own planet.
It's
so
true. It's
thank
true.
you.
And we're taking data for generations to come. So
Yeah.
it's very exciting.
Oh, I'm out of focus.
Thank you for having me on the show.
Oh gosh, of course.
We've got our purple and orange going on here.
Yes,
so
yes.
it's all good.
We're Psyche proud. And now you can continue to follow along this mission by scanning the QR code on the bottom of your screen. This is the one last QR code, guys. It'll take you to nasa.gov/Psyche. And together again, we are going to discover the mysteries of both Psyche and our home planet. And please join us again tomorrow at 11:30 a.m. Eastern for NASA's coverage of the annular eclipse, the Ring of Fire, a celestial
Okay,
event
I've broken the camera.
right here on NASA
Come on.
TV. Everyone, have a great day.
Right, bear with me, guys. I'm having a problem with my camera. There we go. Right, okay. There we go. Right, guys. Well, that was it. That was our Falcon Heavy launch. So that makes 2 a year now. So I'm just going to look at the stats, because I believe that makes... Yeah, that makes the 8th launch of Falcon Heavy 100% success rate. So it is, it is crazy that they've managed to do this. But yeah, guys, thank you very much for watching. I will be live later on tonight for a... I might change it. It says GTA, but I might change it to KSP2. Or I might even play a different game. I've got a few games on my list that I want to try. So yeah, we might play that. So guys, thank you very much for watching. I'm Lee. Fly safe, land safer. See you guys in the next one. Bye.